we're going to start talking about inequalities. Today, we are just going to look at graphing with our inequalities and some beginning inequalities to solve. So first thing, we are going to be using some open and closed circles when we're graphing. So we need to know when to use each type. We will use an open circle if it's a less than or a greater than. We use a closed circle if it's less than or equal to, greater than or equal to. So can you tell me what would cause us to use an open versus a closed? What's the difference?
The line under it.
Yep, if it has an equal to, then it becomes closed because it includes those points. If it does not have an equal to, then it is open because we are leaving out certain points. Alright, so first we're just going to graph some inequalities and make sure we know what they mean. So we have to know the difference between less than and greater than. That is the first struggle. Less than is this symbol. So it's telling us we want everything smaller, so that would be everything to the left. Greater than is this symbol, so it's telling us we want everything bigger, so everything to the right. So if I look at number 1, x is less than 3. So first of all, would it be an open or a closed circle?
Closed.
It'd be open. There's no equal to. So we are going to do an open circle at 3. If it's hard for you to see on your graphs, I don't mind if you do it like above the graph if you're having trouble seeing what's what. And then we look, x is less than. So that means smaller. So which way would I keep going? To the left. So we have an open circle here. We want everything to the left. Again, if you can't see it on your number line, you can draw it above. That's also okay. You don't need both of those, one or the other. Number 2, x is greater than -1. So open or closed circle? Open because there's no equal to. It's at -1. And do we want things bigger or smaller? Bigger. So we go to the right. Right. Number 3, x is greater than or equal to 7. So at 7, it would be a closed circle. And we want things bigger or smaller? Bigger. As long as your x is on the left, this is really telling you which direction to go. The arrow is pointing to the right. Here the arrow is pointing to the left. So you can think of it that way as well. This one, would it be open or closed? Closed because it has an equal to. Which way is it going to extend?
Left.
Left. It's saying x is less than, so it's smaller than the -5. Okay, so all of those numbers, the lines, what the line covers, those are the solutions, the numbers that would be smaller than -5. All right, the next ones kind of flip it around. They give us the graph, we have to write the inequality. So I have x. This one was extending to the right, so it's less than. Does it have an equal to? No, because the circle wasn't closed. And my x value would be -2. The x's were less than -2. All right, what would number 6 be? All right, you guys do 6, 7, and 8 then. So this one, x is greater than or equal to 4. Would it be okay if you wrote 4, flip your inequality in the x like that?
Yeah.
Yeah, those are equivalent as long as you flip that inequality. This one, x is less than or equal to 0. Again, we have the equal to because of those closed circles. This one, x is greater than negative 3. So we did pretty well on those. Any question about that? Okay, now we're going to talk about solving our inequalities. With that, there is something we need to remember. We have to flip the inequality when we multiply or divide by a negative number. You did?
Yeah.
Impressive. So with inequalities, if we multiply or divide by a negative, we flip that inequality symbol. Otherwise, it's the same as solving an equation. So all the same steps. So let's solve one. If this were an equation, we've just solved a lot of linear equations. So we should be able to do this. What would we do? Subtract our 2. So 3x is less than negative 6. And then we would divide by 3. Do I flip it?
No.
No, because I didn't divide by a negative. So I get x is less than negative 2. That is my solution. I want to graph this solution. You'll notice I gave you a number line, but I didn't put any numbers on it. You don't have to start at 0 every time. I know I need a negative 2. So just remember, as you go to the right, the numbers are bigger. As you go to the left, they're getting smaller. So you can start your number line wherever you wanted. I just put negative 2 in the middle. Then as I went to the right, the numbers increased. As I went to the left, they are decreasing. So when I graph this, it would be an open circle at negative 2. And I would extend my line off to the left because it's everything smaller than that. Alright, let's try the next one. What would we do first? Subtract our 2, trying to get x by itself. So x divided by 6 is greater than negative 3. What's the opposite of dividing by 6?
Multiplying.
So we multiply each side by 6. These cancel, so we get x is greater than negative 18. So I definitely don't want to start my number line at 0. I'm going to put a negative 18 on here somewhere. I don't even care if you just want to label every other one. That's also an option. So this is negative 18, so that would be negative 17, so this is negative 16, negative 19, negative 20. You can't only label the single number, at least label every other tick mark on that number line for me. So greater than, no equal to, so an open circle, and it's everything larger, so it would extend to the right. Okay, I want you guys to try. Well, let's do 11 together and then I'm going to give you a couple to try. What's my first step?
Subtract 8.
It's like solving an equation, so we subtract 8. So negative 7x is less than or equal to negative 7. If I divide by negative 7, when I do that, my inequality flips. So instead of a less than, it's a greater than or equal. Negative 7 divided by negative 7 is positive 1. So on my number line, if I wanted to label a few numbers, because of the equal to, be a closed circle at 1, and it's everything greater. Alright, I want you guys to try 13 and 15 for me. First step is to add over the 5. We have negative 2x less than or equal to 24. Divide by negative 2. Because it's a negative, the inequality flips, so x is greater than or equal to negative 12. So you have to have negative 12 somewhere on your number line. Doesn't really matter where, but you have to label. If you don't want to label every tick mark, at least every other. Is everyone okay with how I'm numbering? Putting my number lines. You guys understand that? Greater than or equal to, so that would be a closed circle and going to the right. Okay, problem 15. If I subtract my 5, we have 3/4 x is greater than 6. How do you get rid of that 3/4? You can do it as a decimal. Can you divide by 3/4? You can. It's maybe not the easiest option. You have to remember, if you're doing it on the calculator, put the 3/4 in parentheses, or it will give you the wrong answer. Another option, you could multiply by 4/3, multiply by the reciprocal. So all of those options work. Is everybody with me? So then we get x is greater than, because it's positive, it didn't flip, 8. So on my number line, I have to have an 8. Greater than, so no close circle going this way. All right, one final problem. Let's look at 14. What's the first step here?
Plus 33.
So negative 4x is less than 28. When you divide by a negative 4, what happens?
You flip the
Inequality. So x is greater than negative 7. So you need a negative 7 somewhere. Greater than, so open circle going to the right. Okay, how do you guys feel with this stuff? Any issues at all? Do we need more practice? Okay, I'm going to give you a handout. We have a lot